Okay, this is Dr. Kraus with a video on blinking an LED. This probably crosses the line into doing your homework for you, but I don't want anyone to get hung up early in the course on some small detail that gets really frustrating or something, and so I just want to make sure that we're moving this along. Yeah, my code will essentially blink an LED for you. It won't do the SOS Morse code assignment for you, and so you'll have to extend on it, and you'll have to hack it just a little bit to get it down to only one LED my code blinks for. But I think those are pretty small things. So in order to make this work, there's some key elements. One, and this is kind of going to be true of most projects in this course, there's going to be some hardware considerations. You've got to construct a circuit, although it's a simple circuit of an LED and a resistor. You have to have a resistor, or you will burn out your LED by trying to put too much current through it. Essentially, an LED is a short in one direction and an open in the other. And so in the short direction, if there's no resistance, then it would try to just suck up as much current as possible. And you'll either damage your LED. If you're lucky, you might just pull as much current as the Raspberry Pi can source and not do any damage, but I wouldn't try it. So make sure you have a resistor. That resistor should probably be 300 to 500 ohms. I wouldn't go smaller than 300, and 300 it makes them nice and bright. 500, depending on your LED, might make them slightly not as bright. And certainly if you don't remember your ECE 210 kind of stuff, I just had 1000 Ks laying around, or 1 K is laying around, 1000 ohms. So two of those in parallel obviously makes a 500, so if you need to. You got to get your LED polarity right. Fortunately, this isn't damaging. It's just that if you hook it up in the direction where the LED is the short, then no current will, is the open in the blocking configuration, then no current will flow and the LED simply won't turn on. So you got to get that right. And then you got to connect to the right Raspberry Pi pin or nothing will happen. Well, probably. So some pins are always 5 or 3 volts, 3.3 volts. Some are always ground, and then some are user controllable. So if you happen to pick a wrong pin that was already 5 volts, your LED would just stay on. If you happen to pick a wrong pin that was a ground, it would just stay off. And then if you were trying to control a different pin than the one you were connected to, probably just nothing would happen. And so software-wise, you've got 3 options. RPi.GPIO is probably the simplest option and is perfectly fine for this LED flashing assignment. Long term, I think I want to push you in the direction of RPi.GPIO. I think that's the most powerful and the fastest library out there. Wiring Pi is pretty good, but not quite as well documented as RPi.GPIO. And for I've got this robot project where I want to drive and I want to turn by driving the wheels differentially, so I need 2 different PWM signals, and RPi.GPIO, as I've played around with it, supports dual PWM via software very, very nicely. Wiring Pi seems to mostly just want to do the one hardware PWM that's already built into the Broadcom chip. And I haven't had as much success, although I didn't try very hard, with Wiring Pi software PWM. So either use RPi.GPIO, which is easy and kind of built in, or start playing with RPi.GPIO now. No matter what you do, you got to configure the pin that you're using to control your LED as an output, and then program that thing to go on and off, which requires understanding the pin numbering conventions, which are a little weird. And so the main thing to know about LED polarity is that generally it'll come with a shorter lead and a longer lead, and the longer lead is the one you'll connect to the positive voltage side of the circuit. There's a tutorial on SparkFun that I think is pretty decent that talks about polarity of diodes and LEDs, and I stole this picture from that tutorial. Here's a longer lead and it's positive. Pretty straightforward. Okay, probably the most important and weirdest part of this video is understanding the Raspberry Pi pin numbers, both where is pin 1, where is pin 2, where is pin 40, how do the pins go, but then also there's at least 2 if not 3 different conventions for numbering the pins. One is to use the pins 1 through 40 that are on the GPIO header on the Raspberry Pi, which doesn't seem like very many people do, or use the Broadcom BCM pin number that actually refers to the pins of the chip that is the processor of the Raspberry Pi. And so I'm going to push you in this direction, partially because RPi.GPIO seems to only think in terms of the BCM convention. And so if you were to Google Raspberry Pi, I think I have this already Googled, Raspberry Pi 3 pinout, and then under images, this kind of middle one is in my mind the most helpful image I've seen on this subject, partially because it has the Raspberry Pi pin numbers 1 through 40 clearly identified, and then the name of the pin from a BCM naming convention, and so GPIO 17 is here on pin 11, for example. But then it also has this handy picture that shows what these correspond to. So pin 1 is this pin right here. If you've got the USB ports on the bottom, then pin 1 is at the top on the inside, and pin 2 is at the top on the outside, and pin 40 is the bottom outside. So 1, 2, 3, 4, 5, 6, 7, 8, and so on. Most helpful picture on the internet, so I stole it. There's this Google legal disclaimer. It says this image may be copyrighted. That's true. I can't find the copyright, or I would give credit to it, and I don't know who owns this GitHub. And it's github.io. I don't even know where .io is. My GitHub account goes to github.com, so I assume .io is either some other country, or GitHub is just specifically saying this is for, I don't know, input, output, who knows. At any rate, so just to be 1,000% clear, if I go over here to a picture of my Raspberry Pi, so like I said, USB ports at the bottom mean that this guy is pin 1, top inside. Then this is pin 2, top outside, and then 3, 4, 5. So this is pin 6, which is my ground. And if you look at the rest of my connections here while we're on this subject, so 7, 8, 9, and 10 are not connected. And then I've got something on pin 11 and 12, 13, not 14, and 15. So 11, 12, 13, and 15 are the connections to my, so 6 is the ground, 11 is going to this top LED here, bend that out of the way, and then 12 is going to here, and 13 is going to here, and 15 is going to here. And if we flip back to this diagram, that means that I'm using GPIO Broadcom pins 17, 18, 27, and 22. So we'll see that in my code later, but I'm going to blink. So I'm telling GPIO module, after I import it, to use the BCM pin numbering mode, and I'm telling it to use pins 17, 18, 27, and 22. And so that corresponds to the board pins 11, 12, 13, and 15. Super confusing. This diagram needs to be ready at hand whenever you're doing these kind of things. And if you're talking to team members or something, if you're doing a group project, you got to agree ahead of time. Are we BCM people or are we board people? And like I said, I'm picking Team BCM mostly because RPi.GPIO module explicitly uses BCM. That's all I have to say about that. But make sure you know and have this picture close at hand in case you have to go back and forth. Because obviously nobody's going to go, okay, hook up to pin GPIO 17 and know where that is. You're not going to know. So you got to know that that's pin 11 on the board. Okay, and so my code, the code that I just showed you, is on GitHub, and you can click this link, and hopefully that will just work and take you to some code that you could copy and paste. Or if you've decided that you want to learn to use Git, then the command is git clone, and then this is my GitHub account with the repository blink.git. And like I said, that'll take you to here. I don't know if there's anything else you need to know. So you're just trying to do one LED, so you would just pick one pin. Like I said, I'm using physical pins 11, 12, 13, and 15. And then those are coming over to the positive sides of my LED. And then I've got a resistor to ground. And in most cases, I actually could have cleaned this up. I went to campus and got some 330 ohm resistors. But I've got two 1 kilo ohm resistors in parallel to make 500 ohms. And if you look at my code So for each pin number, it's going to go in here, and so pin will be 17, 18, 27, and 22 each time through the loop, but I'm using this enumerate, which you could Google, and basically it's a way to make Python also put out an index number, and so this will be, so I will be 0, 1, 2, and 3 each time through the for loop automatically. And so then I'm coming in here with a nested for loop using I plus 1 as my stopping point. So the first time through, I would be 0, J would execute this for loop just once. So the first time through, it's going to blink pin 17 one time, on for half a second, off for half a second. The second time through, it'll run the inner for loop twice. So you'll see the second pin LED blink twice on pin 8 on GPIO 18. And then the third time through, GPIO 27 will cause my LED to blink 3 times. And then on the fourth time through, we'll run the inner for loop 4 times, blinking GPIO 22 4 times. So let me run that and just kind of show that to you. Although, so I'm on VNC, I'm ready to run this. You kind of got to want to see it. So let me kill the lights in my dining room, and we'll do that one more time. Ooh, very dramatic. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. So again, key ideas. I know my pin numbering convention. I understand what pins I'm controlling. I've got a ground. I've got resistors in the 300 to 500 ohm range. I've got the longer lead of my LED connected to positive, which the pin gets turned up to 3.3 volts. And then code-wise, I know how to import the GPIO module or submodule of the RPiO module. I set up that I want to use the Broadcom pin numbering convention. I tell it what pin I want to use. I set that pin as an output. I set it high for half a second. I sleep. Well, I set it high, sleep for half a second. Set it low, sleep for half a second. And then whenever you do this at the end of your code, you're supposed to clean up. Tell GPIO that you're leaving. So let me know if you have any questions. Thanks. Bye.